Hi, everybody. So I am so excited to be doing my first screencast without any glitches whatsoever. In this screencast, we're gonna talk about factoring polynomial expressions. This is going to be a comfortable review. Okay, a couple of things. Factoring. What factoring means. Okay, factoring means expressing as factors. Okay, expressing as entities being multiplied. We are going to be factoring polynomial expressions, which means the expressions that we'll be looking at will only have non-negative and integral degrees for their terms. And we're looking at expressions, okay, not equations. We're just merely factoring. And this should serve as a very comfortable review, all right? All of you have seen this in Math 2. There's a couple of special patterns here that you may or may not have seen, but I'll still give them to you nonetheless. Essentially, when you're factoring, I think I like to think of, the a triage effect, all right? And there really is only, there's really only one first step that we can never forget. And that is, looking for a GCF, okay? If you have an expression and you look for a GCF, and if there is one, that will always simplify the expression remaining. And often the expression that remains will be easier to factor since that GCF has been factored out. And then step 2, I'm just going to write here, assess. Okay, because after step 1, there are many different things that you could possibly do depending on what you have. So let's begin together. Okay, let's take a look at something. Let's take a look at some expressions. All right, let's just take a look at some of these. And again, this should feel like a really comfortable review. Okay, so here's a first one. Okay, so here's an expression. It is polynomial. It's polynomial in 2 variables, which is something that we won't work with a lot in this class in the realm of equations or graphing relations, but in terms of factoring, we can. So here, the greatest common factor is going to be 12y. Okay, 12y, when you factor out the 12y, what you're left with here is 3xy plus 2. Okay, and if you look at the remaining factor, and again, just to make sure we're all on the right page vocabulary-wise, when we factor, there are 2 factors now. Okay, this here is an expression of terms. This here is an expression of factors. Okay, and this expression has been fully factored. You've also looked at factoring expressions that are degree 2 or quadratic. For example, okay, here's an expression I'm going to ask you to factor. The first thing you check, is there a GCF? There is not. So then we assess. Well, we assess, and here in this case we have a degree 2 trinomial. Degree 2, 3 terms. And probably the language that you used in the past is, oh, we just try to unfoil, which I'm fine with. Actually, no, I'm not fine with, I have to be honest. I actually hate the word foil and unfoil. Foil is just another word for this distributive property, and unfoiling is just another word for factoring. But in any case, what you would likely do is this now. Okay, and this is now the factored expression of this quadratic trinomial. All right, you may have also seen something like this back in the day. You may have seen this special pattern. In fact, I know you've seen this special pattern. Like, how about this one? 4x squared minus 81. Okay, this is a quadratic, and you may have recognized that this is in fact a difference of squares, and differences of squares factor in this way. Okay, this is often written as, in generally speaking, this pattern says a squared minus b squared will always factor as a plus b times a minus b. Okay, this is the difference of squares pattern. All right, you may also have seen, let's just go from the most familiar to the least familiar. Maybe you've seen this. Okay. And when you factor this quadratic trinomial, once again, check for a GCF. There is none. You will find that this factors as such, okay, which is the same thing as x plus 8 quantity squared. And a quadratic trinomial that factors such that the two factors are identical has a special name. Do you remember what it is? This is called a perfect square trinomial. Okay? So this is just factoring, maybe call it like JV, right? There's some special factoring patterns that you may see. You may have seen some things like this. Let's just call this special factoring patterns and methods, okay? Special factoring patterns and methods. I just love this new version of the screencast, and you're gonna love it too, because I can upload these right up to YouTube and I can paste the link directly into the calendar. So there's no clicking around on your end to find the screencast. And the visual and audio is going to be so much better for you. Yay! All right. The first pattern that I want you to see is this one. It's called expressions in what I call quadratic form. Okay? Expressions in quadratic form. Let's first define quadratic form, okay? Let me give you an example of an expression in quadratic form. 3x to the 10th plus 10x to the 5th plus 3 is in what is called quadratic form. So let's define what quadratic form means. Quadratic form means the following. You have a trinomial, there is a constant, the degree of the trinomial is 10, and then the degree of the quote-unquote middle term is always half the degree of the trinomial, all right? And the reason why quadratic form is really nice is we can do this substitution. We can say, let u equal x to the 5th. Okay, if u equals x to the 5th, then look what happens. 3x to the 10th plus 10x to the 5th becomes 3u squared plus 10u plus 3. And if you look at this, this is none other than a quadratic trinomial. Okay, and with this substitution, all you have done is you have rewritten your expression in explicit quadratic form. Okay, explicit means explicitly quadratic form. This is in quadratic form in that with the substitution you would have a degree 2. And then now when you factor, you probably see it fairly quickly. And again, I did check to make sure that there was no GCF, and there is not. And at the end of the day, the factorization will be this. I'm going to go back to my sub, and here it is. Okay, so recognizing quadratic form, once you get comfortable with it, and you may already be, given your work last year, you can actually skip this step. You can just go straight from here to right here. Okay, like once you get good, you can skip the step where you show what u is equal, and you could just go directly bam to bam. Okay. All right, the other pattern I want to show you is this, or the factoring technique is something called factoring by a method called grouping. Okay, factoring by grouping. And it's not all the time, but factoring by grouping usually, generally speaking, okay, generally speaking, we will look for this possibility when I have 4 terms, generally speaking. You know, like I said, with math at this level, and then certainly with factoring, there are always exceptions to the rule, right? It could be there can be these little dirty tricks. Let me give you an example. Let's see, factoring by grouping. I'm actually just going to pluck one off of your homework, okay? Let's say I've got something like this, okay? X to the 6th minus 2x to the 4th minus 8x squared plus 16, okay? All right, so the first thing I'm going to do is I'm going to look at this expression and make a mental note. There is no GCF, okay? So I'm going to dive in. There's no GCF. This is not a quadratic trinomial, and it's also not in quadratic form, all right? But there are 4 terms, so I'm going to try grouping. Grouping involves the first step of grouping your polynomial, or I should say regrouping your polynomial. So I'm going to do this. I'm going to try and do this. I'm going to rewrite the expression, and I'm going to group it this way. Look what I'm going to do here. I'm going to group, and I'm going to do this. I'm going to group the first 2 terms, and I'm going to group the last 2 terms. Now, you're going to ask a couple of questions. One of them, you're going to say, Ms. Yam, I put this parenthesis around the 8x squared plus 16. I didn't include the minus sign. Didn't I do something wrong? And the answer is yes, I did. Because if I group it with the yellow parentheses, this negative sign would make this minus, right? So I actually have to be correct here and say, uh-oh, if I want to group the first 2 and the last 2 terms, I am going to do this. X squared minus 6x to the 4th. I'm just going to call this plus a negative 8x squared plus 16, okay? And now when I group the first 2 terms here, I'm going to leave the plus sign in the middle. I'm going to group now. Now this is valid, okay? I'm going to put a big fat arrow here and say no, okay? Okay, now the next question you have for me is, do you always group the first 2 and then the last 2 together? Are there times when you might group the first 3 and then leave this one alone? Or maybe you'll rearrange the terms and group the first and the 3rd term and the 2nd and the 4th term. The answer to those questions is yes. There are certainly exceptions to the rule, okay? And if we were going to do an entire unit on all the possible ways that grouping could look disgusting, we would cover all those, but I'm just going to cover right now the most common way grouping will manifest itself. Okay, so when you factor by grouping, you first regroup, and by and large, you regroup first 2, last 2 terms. Okay, and then what you're going to do is you're going to look at these groupings, and you're going to ask yourself, does each grouping have a GCF? And if I look at this first grouping, yes, it does. X squared times 1 minus 6x squared. The first pair has a GCF of x squared. Here's the plus sign. Let's see. This second grouping has a, I just lost my, oh, thank you, has a GCF of negative 8. You know what, boys and girls, I just did something. Do you see what I did here? This is a 2. How did the 2 become a 6? Let's just go and fix that. Doop. Look at how nicely I can erase with this, with the precision of a pencil and not having to deal with the smartboard. Oh, it's lovely. Oop, another one to erase. And if you caught that earlier on, you get a gold medal. All right, here we go. Okay, very good. Here's where I am. Now I'm going to look at this second grouping, and I see that negative 8 is a common factor. And that leaves me with x squared minus 2 inside. Okay, and oh my goodness, Miss Yam, what happened? Hold on a second. Hold on, 1 second. Oh no, wait a minute. Do you know what I just saw that I did, boys and girls? I also saw that I messed this up. What am I doing? I don't know. I am so sorry. This is so embarrassing. I don't know what I did. I think I was just getting so excited that like my hand and my mouth weren't talking. All right, so that means, so let me see, are you fixing this with me here, boys and girls? I hope you are. So x to the fourth is a common factor. Oh my gosh, and that means, okay, oh, come on, Yam. What are you thinking? X squared minus 2. Okay, here we go. All right, so now here's what I've done. When I've taken the GCF out of both groupings, here's what I've got. Now, some of you would say, why did you think to take out -8 here? Why didn't I take out +8? And the answer is I could have taken out +8. And if I factored out +8 instead of -8, I would have had -x squared plus 2, okay? So I was thinking ahead of myself. I saw that if I factored out -8, what would remain here is this. I would have this in common, okay? So that's why I thought ahead and said I'm going to take out -8. Because now when you look at this, if you look at this expression, look at the expression as an entirety, all right? I have term 1 plus term 2, right? And those two terms have a common factor of x squared minus 2, all right? And when I factor x squared minus 2 out of the first term, I'm left with x to the fourth and then -8, okay? And now I'm going to actually go a little farther. I would like you to, if possible, express these two quadratic and degree 4 factors, if possible, as linear factors. In other words, can I factor x squared minus 2 further if I allow for the possibility of irrational terms? So x squared minus 2 I could think of as a difference of squares, x minus root 2 times x plus root 2. All right. Notice now I have degree 1 factors. Degree 1 factor. This is a degree 2 factor. Could you take this degree 4 factor and factor it down further? Go ahead and pause me and try it. Okay, so I'm going to do this because x to the fourth minus 8 is also a difference of squares. X squared minus root 8, x squared plus root 8. Okay? Now, what's interesting here is degree 1, degree 1, degree 2, degree 2. Look at this degree 2 right here. This degree 2 is a sum of squares factor. Sum of squares are prime. In other words, a sum of squares cannot be factored further. Okay? You cannot factor a sum of squares further. However, x squared minus root 8 can be, and this is just, again, a difference of squares. Now, root 8 is just 8 to the 1/2. If I factor x squared minus root 8 further, what do you get, boys and girls? Yes, x minus fourth root of 8 times x plus fourth root of 8, okay? And then these linear factors are still staying here. Okay, and then what I've got here is, oops, I can't fit this in. Let's see, I'm just going to erase this because I can't fit that one. I have my little conversation here. Oh, okay, then I've got x squared plus root 8. And here is a complete factorization of the original degree 6. All right, that's factoring by grouping. Okay, two other patterns I want to show you. So we know the difference of squares pattern, right? We know sum of squares cannot be factored further, all right? There are two other patterns. Let's see, we're number 3, number 4. Number 3 is called the sum of cubes factoring pattern. And again, something you've likely seen before. So I'll just give it to you. So a sum of cubes factoring pattern says the following, that if I have, okay, u cubed plus v cubed, this will always factor to be this. Okay, so here's an IE. For example, if you are told to factor the following? Okay. Again, ask yourself a couple questions. Is there a GCF? No. Okay, there's no GCF, so now you assess. This is not quadratic. It's not in quadratic form. There are not 4 terms, so I'm not going to go to grouping. But I say, oh, I have a sum of cubes. Okay, because x cubed plus 8 is the same thing as x cubed plus 2 cubed. And now I know that this will factor to be x plus 2 times x squared minus 2x plus 4. Okay, and I'm going to box this. Well, actually, no, I'm not going to box it yet. I'm going to ask you, could this quadratic trinomial be factored further? Okay, can this be factored further, yes or no? Go ahead and pause me and see if you can answer that question. Okay, the answer is this quadratic trinomial cannot be factored further. So this is the final and complete factorization. Okay, final factoring pattern is the, you guessed it, difference of cubes factoring pattern. So you'll notice that sum of cubes can be factored, sum of squares cannot. All right. The difference of cubes factoring pattern is the following. And I'll just give it to you right here. It says that u cubed minus v cubed will equal u minus v times u squared plus uv plus v squared. Okay, so if you're looking here at the difference here is, let's see, you can say, well, this sign always matches, right, the sign of the original expression. And then maybe you could say that, oh, this sign right here is opposite that one, right? Come on in. Yeah, come on in. And that both of them share a positive v squared. All right? Okay, so that's the screencast for this. Again, this should have been a review, a comfortable one. And I hope that the audio and the visual was better. And what I'd like you to do is, now that you've done this screencast, listen to this screencast, make sure you do the homework associated with this. It is in the handouts folder, and I believe it's titled the 9/5/17 homework, and it's a PDF, okay, asking you to factor in the handouts folder. All right. Okay, excellent, and I will see you later. Goodbye.